Hello and welcome to lesson 5 of our Java game programming tutorials. So, I left you with a challenge last time. I'm just going to get right into it this time. I'm not even going to talk about anything. All I'm going to say is that, last time was a good starting point. Today is not a good starting point. So if you're just getting into the series, I definitely recommend starting with last episode, not this one. But anyway, yeah, last time I gave you a challenge at the end of the episode, and that was to implement these two new parameters to our method. That is x zoom and y zoom. And I think I might have given you a little hint. I actually completely forgot if I gave you a hint or not. But if you have not figured this out, I'm going to go ahead and start programming this, and feel free to pause whenever you want to and see if you can figure it out for yourself. So I'm creating another variable here called x zoom position, and that's going to be kind of our index for this for loop. And this is going to loop for every x zoom position. Sorry, I kind of combined two things here. X zoom position. So that's not x zoom. This is going to loop for every x zoom that we have. Okay, this is a completely different variable. We're not touching x at this point. We're not touching y. We're just creating a new variable called x zoom position. And actually, I want to do the same thing for y zoom position. And it actually doesn't really matter what order you do it in, because the nested for loop is going to do the same thing either way. But I'm going to do it in this order because that's the same order I had it before. Y zoom position. Like I had y then x here. I'm going to do the same up here with y zoom and x zoom. So, yes. And I'll explain this. This is still kind of in challenge mode, so as I said, pause whenever you want. And I'll explain how this works later. And this isn't all you need to do. There's also stuff you need to change in this line. So if you want to pause and try to figure that out, now that you've kind of gotten this to start you off with, let me just make sure that compiles. Yeah, now you've got this to start off with. Maybe you can try that out. If not, I'm going to go on and I'm going to tell you what must be done. Okay, well, I'm assuming that you were done. So right now, we are looping through every pixel in our image. This is what these two for loops are doing. But then we need to do an extra step, because not only do we need to loop through every pixel in our image, we need to loop through for every single time we want to put that pixel onto the screen. So the y zoom variable is how many times we want the length of that pixel we put on the screen. So like that same pixel we put down in y zoom, as many times as we have for y zoom. So like if y zoom was 5, that pixel would be put in height order 5 times. For x zoom, that pixel will be put like next to each other on the x-axis, that as many times as x zoom. So that's kind of how that works. So once we get into the middle of this for loop, we're actually finally setting the pixel, right? So we have this pixel here that we've gotten from the image. We're not going to touch this at all because we are still getting the same pixel from the image. We don't want this to be affected by x zoom or y zoom at all, because we're still going to get the same pixel from the image for each of these two for loops. What we just need to change is the place where we put it on the screen. So the first thing I'm going to do is I'm going to factor in x zoom position in our two x and y position parentheses here. So if you're forgetting what this means, x position is the position that offset from the top left of the screen. Well, these two position variables are offset from the top left of the screen, and they're kind of where we want to start rendering our image from. And then the x and the y variables here are is the current pixel that we're at in the image, and the offset from that. And we're adding that into the screen because that's how far we are off of the left of the screen as well. But that is changed now because we're not just x away from the screen, and we're not just y away from the starting position. We're instead y times a factor of y zoom from the top of the screen, and x times a factor of x zoom from the left of the screen. Okay, so this will work now. This is what we've done. We've got this all implemented. This is how it works. There's one extra thing we can do, and I'm not sure why I didn't do this a while ago, but we want to get rid of all of these brackets because we don't need them. Because all we have is one statement in our for loop, so it'll work without any of those brackets. So yeah, that is actually it. We have just the reason why, and this was like a real challenge for probably a lot of you, but we factored in you know, we factored in the zoom for X and Y, not just in the offset from the start position, but also we added in the offset as well. And actually, let me just think about this, because there is a reason why we're doing that. Oh yeah, because yeah, that's actually how many times we're looping through, like how many offsets we have. This is really difficult to understand, but yeah, it works. Right, X times X zoom, because that's how far we are. This is kind of factoring every other pixel's, you know, X zoom, so we don't just overwrite the other pixel's X zoom. Like if we got rid of this, we'd have a. In fact, let me just get rid of that, and I'll show you what happens if I get rid of X zoom and Y zoom. And actually, I think in game I need to. Oh no, okay. I did this. You might have not. You need to go to render image and put in the two parameters from last episode, the X zoom and the Y zoom. So now if we run this without those, as you can see, it kind of has this weird extension thing, right? And that's because it's trying to overwrite pixels and extend it a little bit more. So what you actually need to actually like put this factor in the X and Y zoom for the other pixels on the screen. And that's what this part's doing. So if you don't understand this, I know it's difficult, and maybe at some point you can understand it. So now if we go ahead and try this out with those two 10 by 10, we've just kind of actually zoomed the image 10 by 10. So I think that's pretty cool. And we can do as much as we want. I think we'll have trouble if it goes off screen. Maybe we won't. Yep, we will. So right now, we're getting array out of bound exceptions when we are rendering off of the screen. So if I try this, pixel small, I think that'll still go off the screen. Oh, it won't. Wow, that's maybe exactly on the screen. Yeah. So that's that's a big grass tile. So anyway, we're getting array out of bounds exceptions when we render this stuff off of the screen. That's because it's trying to access parts of our screen array that don't exist. And I think we just want to remedy that problem right now. And I'm not just going to do a try statement and catch array out of bounds exception. That's not really cool. I think what we need to do instead is we need to check to make sure that our pixel that we're trying to set is in range. And I'm actually going to do this in a separate method to make this a lot easier later on and also now. And I'm going to call this method setPixel. And all it's going to take is an X, a Y, and the pixel. Although maybe we can do into pixel, into X, and into Y. So pretty much what we do is we would call setPixel. We'd pass in our pixel we're trying to set, which is the pixel we're grabbing from the image pixels. So we're just going to copy that in. The next parameter is X, and this is the X position. Yes, that's the X position. This is the Y position. And that's all we need to pass in. So what this is going to do is essentially copy this down. Okay. So now if I copy this down, we are setting, instead of all this factoring in stuff, we're just going to set X plus Y. So X plus Y, get rid of all of this, times view.getWidth equals, and this is going to be pixel instead of, so that's kind of like what we had initially. This is the simple down version of what we had initially, because all we're passing in is the X position, or sorry, the pixel, the X position, and the Y position, and we're factoring that all in here. But before we actually do this, we want to actually figure out what pixel it is first. So what I'm going to do is I'm going to say pixel ID, or maybe we can say pixel index, is going to be equal to that stuff that was inside of here. Okay? So I'm just going to relate that to pixel index. And we're just going to check to make sure that pixel index is within the pixels range. So we're going to do if pixels is less than or equal to pixel index. We're going to pixels.length, So pixels.length, the length of the amount of pixels we have on the screen. Because if you call the .length property of any array, it'll give you the amount of, like the maximum length you can have. Or sorry, like if you have three elements in an array, right? 3 elements in an array, it'll give you 3 when you do pixels.length. So there you go. So that's what we're doing. We're just checking to make sure that our pixel index is within that boundaries. And if so, we're going to set the pixel. Now, I think I'm missing a I have too many parentheses, maybe? No? Set pixel, we got that. Yeah, I'm missing a parenthesis here. Although we can just probably get rid of that, and then we're probably good. There we go. All right. So if we run this, it'll probably run the same way, except it won't crash, maybe? Set pixel. Pixels.length is less than. Wait, no. Greater than or equal to pixel index. My problem. My bad. So we want to make sure that our pixels.length is greater than or equal to pixel index, not the other way around. Because we need the amount of pixels in the array to be greater than or equal to the pixel index. Otherwise, we'll be rendering stuff off of the screen. And did I compile? Huh. Still getting problems, huh? Maybe we should... Okay, so 800,000 is out of range. Maybe that is the problem? Yeah, that was the problem. It's not less than or equal to. It's the reason is because this is a zero-based array. So the length, like if the last pixel, let's say in the array might have been 800,000, but actually that's just what the length of it is. There's 800,000 pixels in the array, but really the last pixel is 7,999 or 799,999 would be the last pixel, but the length of it was 800,000. So that's what the problem was there, because there's a zero-based array. So now we have this grass tile that is zoomed by 100, and it's going off the screen, but it's okay because it's not crashing when it goes off the screen. So that's pretty cool. So we fixed two things. First of all, we got zoom working, and second of all, it doesn't actually do stuff that's off the screen. It doesn't crash when we try to do stuff that's off of the screen. So anyway, let's move on. We've got a lot of the just hard to understand stuff out of the way. I guess we can get rid of this stuff now. So yeah, let's move on. Oh. Now we want to start actually adding things into our game, right? We have a tile right now. But one thing that I can already see us having a problem with in the future with our current setup is that how do we ever move around, right? Because if we move around, don't we have to factor that all in to our rendering code? Like if there's a camera and the camera moves around, don't we have to like factor that all in to rendering everything to the screen? And the way that viewports, I should say, work in video games is that there isn't a camera in most cases, and the camera doesn't actually move around. If you use some like anything like Unity 3D and stuff like that, you're like, oh yeah, but there is a camera. Well, yeah, they give you a camera. They tell you, hey, here's a camera, and you can move it around, and the viewpoint will change. But the way that we're doing this, we don't actually just have a camera that we can move around. And this is the case in the core of every game, to be honest. The camera doesn't move, everything else moves. And that's actually completely true. Whenever you render something, the camera doesn't move, everything else in the game moves. So, how are we going to implement this kind of stuff? Well, the easiest way to do this is to just have some sort of easy way to access our camera. And by camera, the camera is just going to represent an object, right? That's going to have an X position, a Y position, and maybe a width and a height, so that we can offset the screen by that much. And if we're going to implement something that has those kind of capabilities, why don't we just implement a full-on rectangle, right? A rectangle class that allows us to just an object that represents the width, height, and X and Y position of any object that we can create. So, what's a rectangle? A rectangle is a new class that is made only to hold 4 fields. We might add some more methods to it later, but right now all it's going to do is hold 4 fields. And those 4 fields are X, Y, width, and height. Okay? And the X position is going to be the X position of whatever rectangle we're talking about. Same with Y position, and the width and height are the width and height of the rectangle. And we can use rectangles to represent many things in our game, like the camera, which is the user viewpoint, which I was just talking about. Game objects, like the player, so we can maybe deal with, if a rectangle overlaps another rectangle, it's colliding and stuff like that, And even tiles, stuff like tiles on the map. Although we're probably not going to create a rectangle for every single tile on the map. It's just maybe when we're dealing with collisions and stuff like that, we can represent a tile as a rectangle. And for debug purposes or possibly other purposes, you may want to render a rectangle onto the screen. So these are the very simple ways we're going to deal with this. So anyway, let's go and create our rectangle here. Let me go ahead and just get everything set up. So let's implement rectangle here. So let's go ahead and create. I actually need to get to my workspace. Oh my gosh. This is my workspace. Well, this is another workspace. We have a workspace. New. And we're just going to call this rectangle.java. .java. Java. So there we go. We have our rectangle.java class. And let's go ahead and just call this public class rectangle. And as I said, all it has is 4 fields. That is x, y, w, and h. X is the x position, y is the y position, w is the width position, and h is the height position. And yeah, you can do this in Java, by the way, if you didn't know that. You can go ahead and put a comma between all these variables, and it will create them all as integers. That's all on just one line. There's actually something else a little bit more advanced that I was going to implement in later tutorials, but I think we'll just do it now for the sake of rendering our rectangles to the screen and stuff like that. And that is, well, actually, nah, we won't do that yet. I'll do it later in this episode, just not right now. But we need a rectangle constructor to actually create our rectangle. And all this is going to do is set all of the variables. Well, here, we'll have 2 constructors, because you can have 2 constructors in Java. We're going to have int. We're going to just have a constructor which asks for all of the arguments, right? It asks for all of the fields. And that's what I just did. So this will get the x position that is a field in this class. So that's why we got this.x equals x and this.y equals y, this.w, because we're setting these variables to these variables up here, these fields. So we've got that. Now there's actually another constructor I want to have. And this is just if you want to create an empty rectangle for any reason. And all this is going to do is going to call the other constructor and pass in zeros for all of the arguments. So this constructor calls this. And when it says this, it just calls another constructor that's inside of this class. And that happens to be the only other constructor, which asks for 4 arguments. And those are all integers. So we pass in 0, 0, 0, 0 just to fill in all of these variables. And that, right now, is all we need to do for rectangle. So how we're going to implement this is we're going to go into our render handler again, and we're going to create another field. And this field is going to be a rectangle. This is going to represent our, if I can spell rectangle correctly, this is going to represent our camera. So if I go down to view here, we're going to go ahead and create our camera rectangle. And this is just going to be equal to, it's at the x and y position is going to be 0 and 0, because, I mean, that's where it is on the screen, just 0 and 0, the start of our camera. And then width and height are going to be the width and height variables that we have here. So that's how we've created our camera, which is a field in render handler. So now what we need to do is just to test to see if our camera works. So now if I go ahead and say our camera.x position relative to the 0, 0, 0, which is going to be a point, kind of like on an xy axis. You know, it's going to be 0, 0 is going to be a point where everything starts. Let's see our camera.x is going to be 100 instead, right? Then we want everything to, or let's go ahead and say negative 100, because we want everything to be moved forward a little bit maybe. And that camera.y is going to be negative 30. So moved our camera up a little bit, and we moved our camera to the left a little bit more. That's what we did here. And that we can actually just access those variables because we made them public in here. We could make getters and setters, but for this kind of thing, I think we can just make them normal integers that we can access very easily just by doing camera.x and camera.y. Anyway, this isn't actually going to change anything right now. If we were to compile all of this and run, everything's going to stay in the same spot, and that's because we haven't moved anything. You might say, well, we moved the camera, but we didn't. We just moved a variable. We need to actually factor in the camera when we're setting our pixel. And that's another reason why I made this setPixel method, not just because of the checking to make sure the pixel is in the right place, but also because we want to move our camera. We want to offset everything on our screen relative to where the camera is. So there's actually another thing we want to do before we do any of this. We want to make sure that whatever pixel we're talking about is actually in the range of the camera. And the easiest way to do that is x greater than or equal to camera.x, and is y greater than or equal to camera.y. So in other words, are any of these variables going to be in the camera? I'll do C style bracketing again. So is x greater than or equal to camera x? This makes sure that x and y are on the camera. So if camera dot y is 50 and the pixel that we're asking for is at y20, we're not even going to try and render it because that's not going to be on the camera. So if that's true, we're going to go on into the middle here. And actually, there's another thing we want to do as well, which I, for some reason, do not have in my notes. And that is, I thought there was. We want to do camera.x plus camera.width needs to be less, or sorry, x needs to be less than or equal to camera.x plus camera.width. Okay? And y needs to be less than or equal to camera.y plus camera.height. And actually, these are just w and h, not width and height. And that actually should eliminate the need for any of this stuff as well. And I think this is something I fixed in later lessons, but I might as well do this now. So we're making sure that not only the pixel is not on the left or top side of the screen, like over the boundaries of the left and top, but also not over the boundaries of the right and the bottom of the screen, or of the camera. So, I mean, I'll keep this here for now, I think. Especially since we're going to go ahead and factor in our actual camera positions now. So what we want to do is, if this is true, and we are actually, the pixel is in the boundaries of the camera, then we can do x is x minus camera.x and y minus camera.y. So this just offsets all of the points by the camera, where the reason we're not adding it is because that would offset in the wrong direction. So that's really all we need to do. So now if we were to go ahead and compile and run, our image is, because we moved our camera to the left and up a little bit, that's what these two lines did, line 19 and 20 of Render Handler. Our image is rendered to the right and down a little bit than it usually would be. And that's going to be the case with anything else that we call render image to, because we're offsetting every single pixel by the camera. So let's go ahead and do some testing here, actually. Well, no, I'll keep this line here. I'm keeping this line here simply to make absolutely sure this pixel, we don't get any array out of bounds exceptions ever. You know, just to be sure, absolutely sure. There's no reason why you can't be absolutely sure. So anyway, yeah, now we've got an actual viewport, right? We've got something that we have a viewport on, which is actually really cool. And most of the time, you don't have to even think about these kind of things, like in Unity and stuff like that. But we've decided to do that. So anyway, let's move on to something a little different now. Nothing's gonna change. I forgot to do something. One more thing we want to do with our rectangles. As I said before, maybe we want to render the rectangles at some point for debug purposes. So let's go ahead and do a few quick and easy methods. So in rectangle, what we're gonna do to make our life a lot easier is we're gonna create another field, and this is gonna be a pixels field, and this is gonna be the pixels of the rectangle. Okay. And now we're going to have another, because we don't want to really worry about the pixels if we don't need to. You know what I'm saying? Because we don't actually want to, like if someone just wants a rectangle for, like, not to render out on the screen or anything, we don't want to like automatically fill all those pixels and generate graphics and all that stuff. So what we're going to do is we're actually just going to have a method called generate graphics. And if this method is called, then we're going to generate graphics at whatever color is given for this, this rectangle. But if it's not called, we're not going to worry about it, because the rectangle could be used just to check collisions or something. We don't want to render it for any reason. So all it's going to do, this generate graphics method is going to set pixels equal to a new integer array, and the size of the integer array is going to be width times height. And there's one more thing we need to do, though. We need to actually loop through every pixel and set that to the color that's given. So int y equals 0, y is less than height, y plus plus, and for int x equals 0. Oop. X equals 0, x is less than width, x plus plus, pixels x plus y times width equals the color that was given. So it's going to generate graphics and set all of the rectangle to this specific color. And this is the same kind of terminology we used before. We have this, the reason we're multiplying y by width is because we have this many levels of width, and then we're offsetting by that amount of x. So same kind of concept we used before, just filling in all of the pixels with color. Another thing you could do actually as well, if you wanted to make this maybe a little simpler for some people who are used to linear arrays, is you could just do int I equals 0, I is less than this index, I is less than pixels dot length I plus plus, and then just do color equals pixels I. The reason I did it this way is just so we can get more used to this terminology, and both of them is going to loop the same amount, so it doesn't really matter which way you do it. So those are two ways you can do that, and we're just filling in this pixels array with whatever color is given. And you might be wondering, why are we doing that? And the reason we're doing that is because we want to render this using render handler. And the reason pixels is private is because something that's not a primitive type, I don't really like having public access to them. So instead, we're going to create a method which returns an integer array called getPixels. And all it's going to do is return pixels. Okay? And actually, maybe maybe just in case we accidentally do this without generating graphics, we can go ahead and make an if statement. So if pixels does not equal null, we'll return pixels. Else system.out.println, maybe just like attempted to retrieve pixels from a rectangle without generated graphics. Okay, so this is just if in case we make a mistake later, and I need to put this return statement at the end just so we have something. If you make a mistake later in the process, you know, we can make sure that we can just print out in the line, print this out, and you know, tell us exactly what we did wrong. So you know, just to make sure, because if we for some reason try to render the rectangle without generating graphics, that'll fix that problem. So anyway. Now that we've got that done, why don't we go ahead and make a render rectangle method. So public void render rectangle. This is going to take a rectangle, take a color. Actually, not a color because that's on the rectangle. I'm going to take X zoom and Y zoom. Those are the only things you need, because everything else is going to be in the rectangle. Because the position is the X value of the rectangle. And the Y value of the rectangle, and the width and height values of the rectangle. So that's pretty simple. And you might be thinking, okay, well, we can just use all of the code up here. But the problem is right now up here we're dealing with an image, right? So why don't we go ahead and make this, just create methods to make our lives a lot easier as well. So what we're going to do instead of all of this is we're going to have a public void render array, right? And what it's going to do is it's going to take an integer array of just render pixels. We'll call them render pixels array. It's going to take the X position, Y position, X zoom, and Y zoom. And the reason we're doing this is so that we can just put the array for render pix and render rectangle and the array in for render image and not have to just copy the same code down for render rectangle. So all it's going to do is it's going to, if we go ahead and actually we're going to need, we're going to do width and height of the thing we're rendering as well. So render width and render height. So if you want to pause the video, or maybe I'll just give you a little time to copy down those parameters. We want the pixel array that we're getting from either render rectangle or render image in this case. We want the width of whatever we're rendering because we can't just get that from the render pixel array. We want the render height for the same reason. And we need the X position and Y position. And X zoom and Y zoom. So those are the two parameters we need. Now what we can do is we can just copy down all of this, and we need to change a few things. So first of all, it's not image.getHeight anymore, it's render height. It's not image.getWidth anymore, it's render width. And then same thing down here, we have render width, and we have I think that was it. Oh no. Yeah, that's it. Render width. And this isn't image pixels, this is render pixels. instead. And that's actually all we need to change. So we have render pixels down here because that's the name of that variable, not image pixels, because we're also dealing with rectangles, and that's not necessarily an image. We changed render height and render width up here as well. Let's go ahead and compile that, make sure that works. Cool. So now let's go ahead and pass in all those arguments instead of all the stuff we have up here for render image. So we're just going to call render image, or sorry, render array. Image pixels is going to be the array we're passing in from right here. This is what we got that from the raster of the buffered image. And we're also going to pass in image.getWidth, image.getHeight, because that's the render width and render height. And then we're just going to pass in the same parameters we had up here: x position, y position, x zoom, and y zoom. Okay. And actually, I think now we'll make this a public method just for case in any reason we want to render an array from a game or like some other class. I don't know. There might be a reason why we want to do that at some point. So that's what we're going to do. So for render rectangle now, in fact, let's move this all the way up with the other stuff. I'll just put it below render image. Make this a little bit more organized. Makes it make a little bit more sense. So what we're going to do is, assuming that this rectangle has graphics, although maybe we shouldn't assume. Maybe we should see if for any reason it doesn't have graphics. Although, nah, we won't do it because it's going to just, well, nah, we'll do it. so that it doesn't crash. So we're going to go int array rectangle pixels equals rectangle dot get pixels. If rectangle pixels, and we're not going to print anything if this is null because we've already done that here. So if rectangle pixels does not equal null, then we're going to render array rectangle pixels. We're passing in for the pixels. The render width is going to be rectangle.w. Render height is going to be rectangle.height. X position is going to be rectangle.x. Y position is going to be rectangle.y. And x zoom and y zoom we're going to pass in from the parameters that were up in this method. And that's it. We've actually just passed in all of the arguments and we can render a rectangle now. So let's go ahead and run and make sure our image still works. Our image still works with the new stuff we had. So now let's go ahead and test this out with a rectangle. So if we go ahead and do private rectangle test rectangle pulls delete me pulls. Alright, no, you just test rectangle equals new rectangle. The x position will make 30. The y position will make 90. The width will make 100, and the height will make 100. So it should have the same width and the same height. And then we're going to go down and render here and put a render rectangle thing down here. And that's going to be test rectangle. Y position is going to be, well, actually, all we have for test rectangle, or render rectangle, is just x zoom and y zoom. So we're going to make those 1 and 1 for the rectangles. I just want it to render normally. Oh, and there we see. I forgot to generate graphics, didn't I? And it told us. It told us multiple times we forgot to generate graphics. Let's go down here and just do test rectangle.generate graphics. I'm just going to type in a random number, which is going to be probably a color, unless I made that. We'll type in that. That'll work. And then we have a blue rectangle. Cool. So, yeah. And actually, I kind of want to show you guys something as well. Let's go ahead and actually go back to render handler, and I'm gonna stop offsetting the camera for what I'm about to show you. So this still works with the camera offset because that was all in the set pixel method. So what I'm about to show you is if we were to go ahead and set the rectangle's positions to instead like 30-30, something like that, that's going to be rendered over the image, right? And this is because of the linear order in which we have our renders set up here. We're rendering the image before we're rendering the rectangle, right? So the rectangle is rendering on top of the image if it was in the same position. So now if we go ahead and instead render the rectangle before we render the image, then as you can see, that's exactly what happens. So we have a complete linear control of the order in which things render. And this is going to be extremely useful for us later when we're implementing things like maybe multiple layers to our game and stuff like that. So anyway, I just want to show you guys that. Anyway, we know rectangles work now, so let's go ahead and just delete. Well, you know what? No, there's one more thing. One more thing we want to do. And actually, depending on how long this episode's going for, I might stop after this, but there is one more thing. You know, let me just check how long this has been going for. We got 12 minutes on this recording. I might stop it now. Let's see, 12 minutes on this recording. Hold on, let me see. Yeah, I think I'll give you a challenge for next time, okay? So we're going to end it here, and we will start next time with some cool stuff. And if you're excited for next episode we're going to be dealing with actually doing stuff with sprites. And maybe implementing like something that can move around, like we can move our camera around and stuff like that. So that should be pretty interesting. But anyway, what we're going to do, what your challenge is for next time is another generate graphics method in the rectangle, right? Generate graphics. And I'm going to go ahead and put the parameters in here. So border width, what does that mean? Well, here I actually think I can get you a running copy of what I mean by that. There is a rectangle with a border width of, I think, around 10 pixels. Maybe a little bit. No, I think it was like 4. Maybe it was like 4. So what that did is it rendered the rectangle to the screen. And this is actually complete. This is from my notes. So I just ran this straight from my notes. And the color doesn't matter, but the color's gonna be passed in the same way.
Your channel.
It's just instead we have a specific border width right now. So.
Sound muted.
Yeah, sorry. I just had to mute TeamSpeak for a second. So that's your challenge for next time. You need to give me a rectangle that renders on the screen at specific border width. Now, this is a true challenge when it comes to figuring out how stuff works. Well, what am I even saying? This is a true challenge when it comes to figuring out how the screen works and how you can how offsetting works. So I have pixels equal to new int width times height. That's going to be the same as last time. Because we're going to have the same amount of pixels, it's just some of them aren't even going to be full, right? We're not even going to use some of the pixels. We're just going to set the pixels that we need. So what I want you to do is loop through. And you know what? I'll start you off. If you want to render the first row, sorry, esports stuff. If you want to render the first row of pixels, we want to set our x equal to 0, x is less than width, x plus plus, because this is going to be a 0-based array, so we want it to be less than width. And pixels x is going to be equal to color, right? That's as simple as it is. That's the first row of pixels. That's the easiest one to do, the top row of pixels. Now let's go ahead and see what that does. If we go ahead and generate graphics with border width 3, although, no, we need to count for border width. So, yeah. Right now, that's going to just render a single row of pixels. Not unless I don't compile, that is. There it is, a single row of pixels. What we want instead is, and it actually is going to overwrite right now the old pixels because the pixel array is still just as big, and we'll talk about that next episode. So don't worry about that. Just worry about border width stuff. So what we need to do is we actually need to repeat this for every border width we have. So kind of like we had before, int y is equal to 0, y is less than border width y plus plus. And then we have a nested for loop with the x, and we need to do x plus y times width. So that's going to, if our border width is 5, that should repeat our rectangle 5 times. Looks like it's doing that. So yeah, that's just the top line. What we also need is we need to render stuff on the side of the image. So we got this top part. We need the left side, we need the right side, and we need the bottom. So that is your job for next time. I would start maybe with the bottom and then go to the left and right. So yeah, try to figure that out. That's your challenge. Thanks for watching, and I will see you next time.